All right. I think we did it. I think we're live. Hopefully everybody's drank their coffee and is ready to go because, well, I didn't. I'm not. I didn't drink my coffee yet. But hi,
Hey Joss, good to see you.
good to see you. Hi, and good to see everybody else who's joined us. Uh, so this is going to be a bit of an unusual one. We're going to be doing an interview. We'll do it. We'll do a show and tell for the YouTube audience, and then we're going to do a conversation because I want to turn that conversation without the show and tell because we can only just tell, right? We'll turn that into a podcast. So for people who are watching the whole time, don't worry, it'll be fine. But there's going to be a little bit in the middle where I'm going to reintroduce Geoffrey here, and it'll sound like I don't know what I'm doing, which is well, that's probably fair. It's probably not too far from the truth anyway. Okay, so Geoffrey, my friend, welcome. Thank you for making the time. I know this is like I don't make it easy to plan, and I'm sorry about that. But you were super patient and indulgent. I'm super glad you're here.
Thank you. I'm happy to be here. Thanks, Josh.
Yeah. Oh, thank you. You know, I could probably use Timefold to help me with my planning. Actually, um, I think you are. I think the problem that made it so hard for me to find time with you would have been better solved if I had just learned to use and used Timefold. So can you explain what it is and how it works and what and who you are? Actually, start with who you are. Let's do that first.
Yeah. So I'm Geoffrey De Smet. I come from Ghent, from Belgium, and so 17 years ago I started this open source project in my spare time. And a fun fact: the first version of it used Spring. So 17 years ago, for a library it doesn't make sense to use the platform
Yeah.
like Spring inside, right? It's the other way around. Spring uses libraries like
Right.
Timefold, right? But for the first actual version, I still hooked everything up together with Spring, which was I really loved it. I still love it, right? So I did that. And so what it is, it's basically a constraint solver. It's a planning engine, and you can solve all kinds of planning problems with it. And the world is really full of planning problems. Like,
Right.
so, Josh, have you ever been to an airport?
Once or twice, yeah.
So, so what do you see when you walk in? When you walk into an airport, the first thing you see is like an
Absolute
escalator.
trouble, bedlam, chaos.
Yes, and to guide everything into the right order, you see like escalators bringing you to places and stuff like this, and then automatic doors, and all of those stuff needs maintenance, and so
Yeah.
there's maintenance problems, right? So, and when you walk through almost everywhere, you'll see planning problems all over the place. Like in the airport, when you check in your luggage, there's people there accepting your luggage. There's people. You need to have desks assigned to each of the airlines. When you take your flight that takes off of a certain time, when you go through security checkpoint, there's security guards that will check, do the security there guard, and that's where you have a shift scheduling problem. You need to assign security guards to those places. When you go to the gate, somebody has decided which gate your airplane is off, and typically when
Right.
they change the gate, you hopefully it's to a nearby gate and not to a gate to the other side of the airport, right? And each of these things is actually a planning problem. And so what our open source solver does, it's going to help you solve those problems in a better way. It's going to figure out that when we schedule the gate to a particular airplane, to a particular flight, we're going to
Right.
make sure that those match better. That, for example, when we need to change for example, to reduce the chance that we have to change the gate, not have a
Okay.
flight that's going off at 5 and then another one at 5:15. That's too close to each other. And
Right.
when we do change the gate, that it's going to be to a nearby gate and not to the outside of the airport.
Right. See, this is the kind of stuff that I wish people would use because clearly most airports are not using anything close to this level of sophistication.
If
You
you've
have a
ever
big
been if you've ever been on the Belgian railroads, it's pretty much the same problem.
yeah, yeah.
Yeah. When I go to Devox, for example, I get dropped off in the top of Antwerp Central, and I have
Right.
6 minutes to get down to the bottom of Antwerp Central to catch the train there. almost every time I miss it.
It's like 3 levels. Yeah. So for people who are not aware, Antwerp Central is this huge train station in the middle of Antwerp. Beautiful, but also it's like a MC Escher drawing. The levels on top of each other. It feels like you've got zigzags, and it's a knot of a train station.
Mhm.
And there's several levels. It's like 3 or 4 levels before from top to bottom, right?
Yeah. And so when you do all of these kinds of planning problems, what you want to do is for example, when people assign these shifts, when they use technology to assign these trains and these things like that to the track, to the platform they'll stay in, when they will arrive, what time, and stuff like that.
Right.
The more optimal you do that, the better experience you get for the users, but also you actually reduce costs heavily. To give you an idea, one of the big problems we do is field service routing, where we assign vehicles to go to a number of locations, for example, install telco, or do maintenance on elevators, or do maintenance on electricity grids and stuff like that. And by just ordering those routes of those technicians more optimally, you can often reduce travel time by like 25%. And so our open source solver, what we do is it allows you to basically take any planning problem and implement that using Java, using Spring, and then to just say, okay, here's my problem, and now you figure out who does what at which time, right? And the big thing you give it there is you give it a number of constraints. Like, I want to reduce the travel time. I want to make sure that everybody gets, cable is installed. I want to make sure when I send somebody to a certain location, they have the right skill to do that job.
You know what this reminds me of? And I'm an idiot, so forgive me if this is off base. And it kind of clicked because you mentioned earlier. I mentioned to you that I'm at CERN here in Geneva, and you said, "Oh, hey, say hi to Mario, who famously works on Drools, right? Which is a rules engine." Is this have anything to do with the retail algorithm and that kind of stuff?
So the original implementation, now it's called Timefold, but we're actually continuation of fork, basically, of Optoplanner. And so Optoplanner under the hood used Drools. So for more than 15 years, we used Drools as a score calculation engine. Now, Drools is a rule engine, right? So it's not the same kind of problem. So if you have, for example, if you have a decision table, Drools is a really, really good fit. So for example, if you need to say, okay, based how much what is your how much insurance do you need to pay, right? What's your insurance rate? For example, you have a car and it's a certain size and it's a certain speed and you're a certain age and you've had that X amount of accidents. How much do you need to pay? That's a decision table. That's something where Drools is the technology you want to use. You're looking for a rule engine.
Right.
However, when you want to say, okay, I need to assign a number of vehicles to stop at a number of locations, and I need to decide which vehicle goes to which location in which order, then your problem becomes what they call in mathematics terms NP-hard.
Traveling salesman.
Yes, traveling salesman problem, right? And once you hit that kind of level of complexity, you need an optimization engine, right? And so it's two different technologies, but the use cases it's often hard to see which use case belongs to A or B, unless you're into the technology deeply, of course. Right?
I see. And so do these things, I guess, they might even pair well together. Like you might even have an app with sufficient enough complexity where these things might be used in tandem. It makes sense. What you did, like the routing problem, this is huge, right? And we've heard countless. Over the years, I've seen like a DHL or the post office, whatever. They talk about how they only used routes that did just right turns or something like that, or whatever. And they saved millions of dollars or whatever. So there's clearly wins in this. But can we connect the abstract to the real? Can we see a demo?
Yes, of course. Yeah, because the biggest problem in all of this is that most planning problems are hard, right? And you need a technology where we can solve this in an easy way. Because thinking of this is, I'll just show you a simple case here. This is the school timetabling case. and I'll show you the code behind it in a second, but I'll just want to show you what it does, right?
Mhm.
But I just want to, before we get into this, I just want to mention that if you look at all of the planning problems in the world, experts estimate that maybe 5% are solved with real production solvers. So most of them are solved either by humans doing it manually in Excel, right?
Yeah.
If you're lucky in Excel, right? And or automated systems. A lot of automated, homegrown traditional systems.
Right.
But because these problems are so complex, R&P hard, most of those in-house systems do what we call a greedy algorithm, where they assign things in a relatively simplistic way, because these problems are so complex. Now, with tools like Timefold, but there's other solvers, there's other open source solvers and commercial solvers, you actually get much better results. However, using these is often challenging, and that's something we want to change with our implementation. And I'll show you how that works, and you'll still see that. I'll take you through it. So in this particular
implementation open source?
Yes, everything is open source. Everything is Apache. You can download this one and you can try it. You can adjust it, and it's actually been used all across the world. There's people actually, this is a school timetabling implementation, and there's people using this to organize schools, the classes in schools, right? There's people using it for, There's, I remember.
You mean like kids register for classes, and you've only got so many classes that they can go to, and you need to assign them to classes, that kind of thing?
You could do that too, yes. This one is where we need to assign lessons, where we already know which kids does which lesson. We need to assign for each of these lessons to a room and to a time slot. So here we have a number of lessons like math and biology. You can see it's a little bit of made up data. We have Marie Curie teaching chemistry, we have Alan Turing teaching math, and we need to decide. And we need to assign each of these to a room and to a time slot, right? And so so on first sight, this might be easy, right? And so what we're going to do is we're going to hit the solve button, and it's going to actually assign each of these for us, right? But before I do that, let's actually do that. So what happens now is that the solver figures out, okay, if I assign them like this, I get a good solution. If I assign them like that, I get a better solution. And as we give it more and more time, it finds a better and better solution. You can actually see that here at the top. This is what we call the score. And the score consists of two things, hard constraints and soft constraints. And I'll just stop it for a second to just show you what that means. Oh, I don't know why I'm getting the error here. This is live coding is always interesting, right?
Always.
Always. Okay, it's a UI problem. It's not a backend problem. I'll get this fixed, of course, too. Anyway, what we see here is that each of these lessons is assigned to a room and to a time slot. And you can see that math here is assigned to Monday in room B. Now, when we look at each of these rooms, we can see there's no two lessons in the same room at the same time. And that's very easy to do. If I ask you, assign these lessons to these rooms, you just throw them in, and you just make sure that you don't put two lessons in the same room at the same time, right?
Wow. But what if you add constraints?
Yeah, what about the teachers, right? So if you actually look at it per teacher, what you will see is that we also need to make sure that no two teachers has the same room is teaching two lessons at the same time. So if you look at it per room again, and we would actually say, okay, where's Turing here? All right. You can see that Turing is never teaching two lessons at the same time. If we look at Curie and so forth, you'll see that she's never teaching two at the same time. So what we can do is actually look at per teacher. You can see how this is their lessons. For example, Alan Turing starts with math, then some time off, then math. And then if you look per student group, we have the same problem again. And this is actually quite hard to solve. So if humans do this, if you're in school and you have to do this for 400 lessons, this usually takes more than a week. Somebody doing this in Excel, figuring out, okay, how can we make sure that every lesson is in one room at a time, every teacher gives at most one lesson at the same time, and every student has to attend at most one lesson at the same time. And that's just the hard constraints. right? And then you also have the soft constraints. Soft constraints like, I don't want to have more than 2 lessons of math or 3 lessons of math in a row. I want to make sure that per teacher there's enough. It gets bound. It gets grouped together a bit, right? And we'll actually see if we actually solve it a bit longer, that as it finds better and better solutions, it will actually bring these together more, right?
Oh, cool. So you don't have gaps.
Yes, indeed. So I actually deleted a lot of the gaps already. You can see these nice 3 lessons in a row, 3 lessons in a row. And maybe let me just restart the UI and just solve it, right? And what you will see is, so in the first, if you look at it per teacher now, see there's still a lot of gaps, right? And as this 5 soft goes up, 6 soft, 7 soft, it's actually starting to condense those lessons together, and increase the number of decrease the number of pauses between lessons, which increases the quality of life for the teachers.
So, does it actually finish? So is it finished? Looks like it's finished.
Yeah, so I gave it 30 seconds to solve in this case. So if we go to the, so you can solve for, it typically can keep improving. So you can say, if I reach a certain score, I want to stop. But what you can also do, what you typically need to do once you start scaling out, because it's like the traveling salesman problem. Once it scales out, you cannot solve it with all of the computer power on this planet. Right. So what you do instead then is you time box it. And so let me just show you how that works. So if
let's go.
Yep, don't show. And I actually show, here we go. So in here, we have an application properties. This actually sets for how long we want to run the solver. Now you can run it actually unlimited and just terminate asynchronously, do a call to it and say, okay, I want you to stop solving right now. Right. Or you can actually time box it like
where's the screen again? There it is.
Okay. And you can actually time box it like I'm doing right now. I've just changed this line.
Okay.
See, and so that was 30 seconds. So let's set that to 5 minutes.
So if you want to start that spring.io, you would, are you showing us just existing code, or are we going to like, will we eventually see how to create it or what?
So yeah, if you want to create this, you go to start.spring.io, you create your first project, and then you, and I'll take you through some of the classes in here, right?
Okay. And also the build file.
Yes. Let's start with the build file. If you're okay, I'll take the Maven one. I'm a bit more comfortable in that, to be honest. So in the build file, you declare your Timefold version and your Spring Boot version, right? And again, with start.spring.io, this will actually generate that for you. It might look a little bit different than this one, but it's the same principle. And the only real thing you have in there is, besides your Spring dependencies, of course, is your Timefold solver Spring Boot starter. Okay. And then from there, when you then go, you create a domain. So in this domain, I've created things like a room, where I said, okay, I have a room class. You could make this a record these days, and probably should be a record. Yeah, yes, I know, I should have made this a record.
What is planning ID? That's cool.
Yeah, so this is actually not strictly necessary planning ID, but when we have support for a number of features, and some of them work better if they know that, okay, this class has an ID, and it's like a planning ID, and it makes it unique. It's a property that makes it unique. It allows us to do internally certain performance optimizations. Now, if you don't have this, and I can actually remove this if you want this right now, you'll see it makes no difference for this particular use case. This is a little bit overflow here. Now, what this has is, this is just a room class. This is some JSON Jackson information we have here to make it prettier, the JSON we output. And this thing has a name. And then the time slot, the time slot is like, okay, what day of the week is it, right? Monday, Tuesday, Wednesday.
Right.
What time does it start? What time does it end? And that's pretty much our time slot, right?
Yeah.
And then the big thing is the lesson. That's really the thing where you can really see some some changes, so some specific changes around Timefold. So you have the lesson, which has a subject, a teacher, and a student group. So, for example, math, Marie Curie, chemistry as a subject, teacher Marie Curie, and a student group maybe 10th grade or something like that. And we need to assign it to a time slot and a room. And so this is where these things from Timefold come in, and that's the planning variable. That basically means that we're not going to fill that in. We're going to leave that NULL null, and then Timefold will fill it in for us based upon the constraints we set in the constraint provider, which I'll show you in a minute.
Okay.
So we're basically telling the solver, you cannot change the subject or the teacher or student group of a lesson, but you can change the time slot and a room. You can fill that in for us.
Right.
And you need to fill that in not for just this one lesson. We need to fill it in for all of the lessons, and they need to work together, right? You can choose any of the lessons to be assigned to 9:30 and room A, right? But then you cannot put any of the other lessons in that same time slot in the same room, right?
So cool.
And then when you go to the solver, when you go to the constraint, then you have the constraints. So we talked a little bit earlier about the constraints. So the first three constraints are those three tabs I showed you, which is the room conflict constraint. This is the first one there, which says that I don't want to have two lessons in the same room at the same time. The teacher conflict, I don't want to have one teacher having to teach two lessons at the same time. And the student group, similarly, I don't want to have a student have to attend two lessons at the same time. And you can see we added a number of soft constraints too.
Teacher room stability. Okay, yeah.
Yeah, I want to make sure that the teacher has its own room, right? So they can decorate it with math formula or with French translations, right?
You have to erase it every night.
Yeah. And then the teacher time efficiency one, that's the big one. That's the one where we want to make sure that we keep the teachers happy, right?
Right.
And the fun stuff is you can actually turn it around. You can say, I want the exact opposite. Now, I wouldn't do that in production, of course, but yeah. And then the student group, subject variety is just a difficult name of saying, I don't want to have an afternoon of all math, of all French, or all Spanish, right? I want to have some variety in my subject groups. Now, the way you implement this, we've written a functional API to do this. Now, you could write this with for loops, and we support that too, where you just write some for loops. You say, okay, if I have two lessons in the same room at the same time, I want to break a hard constraint.
So does it keep reevaluating those tests and those for loops against all the nodes and the set of possibilities, I guess?
Yes. And so we build up a node network, right? Very much a little bit like a RETI network, but with some simplifications because we don't have to deal with things like what they call inference, where the last node one goes back into the first node, right? Now, what this basically does is that when every time it tries a new solution, right? It says, okay, let me try swapping those two lessons, right? Or like in shift scheduling, let me try swapping those two shifts, or like in vehicle routing, let me try give that visit and that visit, switch that between the two vehicles. Right. What it does is it has to recalculate all of the constraints. And for this case, for example, it has to check every lesson with every other lesson. So every pair of two lessons, it has to check, are those two lessons now in the same time slot and in the same room?
Right. Oh, wow.
Yeah.
That's so cool.
And when you do that, the thing is, we want to do that 10,000 times per second. Otherwise, we don't have a fast solver. And if you don't have a fast solver, you don't get a good solution. So the way to do that 10,000 times per second is something we call incremental calculations with deltas, right? And that's a lot of fun, but it's very hard to write, right? So what we do is, with this API, you write it like this, right, as usual, but under the hood, we make sure that when we swap one lesson with another lesson somewhere, we only look at the delta on the score that those two lessons imply. So that means when there's 400 lessons in there and two of them swap, we are not comparing any of the 398 other lessons with each other. We're only comparing those two lessons with all of the other lessons.
I see.
And that's just an order of magnitude faster. It's not like for 400 lessons, it's 200 times faster. It's a huge performance gain.
Huge.
Yeah.
Oh my. So okay, so we've got these constraint objects. You've got you've shown us the properties that we can use to time box the resolution. You've shown us the annotations and the component model on the data objects that are then fed in and used as part of the solver, the solution. You mentioned there's another file that we should be looking at, which is
well, then basically, of course, you still have the case where you use it, right? So let me just show you that. This is in the in the controller, of course, right? So what you do is you auto wire the solver manager, right?
Okay. Okay. So it's a solver manager of timetable to string. What is string in this case? Is that the planner ID?
It's the job ID, and in hindsight, in the next version, we'll probably just hard code it to string because everybody's using a string.
Okay.
We wanted to make it extra flexible, but yeah, API design wise, it's a bit overboard, right? And so we're learning.
Yeah, I mean, you're using the solver to solve your own code.
Yeah, and so the solver manager, when you look at this, so what we do is I'll just go down here for a second. We say you can do a build. There's a few APIs you can use. This is a little bit more complex one. Let me show you the simpler version, where you just say, okay, solve. I'm going to give you an ID. Let's say this is my first job. And then I give you my problem, right? And so when you put it like this, we're going to give it a problem, which has a set of lessons and a set of rooms and a set of time slots. And then it's going to give us back the problem. We can say, okay, this will actually, you can say, give us the final best solution here. And this will give us back the solution. And from this solution, we can then say, okay, we now have for the solution. So we have solution get lessons, right? And we can then say, okay, let's print out for each lesson the room and the timetable, the time slot, right?
Yeah.
Yeah. And
so
this is
it's really straightforward. You literally just have an aggregate type called the timetable, and then from there you can work with the data set that was fed into the solution, the solver. Okay.
And you can define your constraints as code, which might seem like, yeah, this is absolutely logical, but it is quite unique when you compare it to a lot of the other options you have out there. Most of the time, most solvers prefer you to write your constraints as mathematical equations. And where you basically say like x plus y is smaller than 1, and you use that to build things like, I want to make sure that no two lessons are being taught at the same room.
Like an index or something, okay.
Yeah. And it is interesting. There's a lot of fun math behind that, linear equations and stuff like that. If you ever solve like a matrix, right, it's a lot of fun stuff around that. But it's hard to maintain, it's hard to read. And so we took a very different approach, and we used the delta and the incremental calculations, stuff like this to come up with the same speed and scale out and be able to deal with have the same quality of solutions, but at the same time make it user friendly, make it maintenance friendly, right?
I love this.
Yeah. Now I'm not going to say that getting used to this Streams API is a little bit. You have to get used to a little bit.
Yeah.
But I'm sure. Yeah. So here we're saying for each unique pair, we're saying select those 2 lessons, right? This is actually already some syntactic sugar. What you really want to do is like what you typically write is, let me show you. Do like, okay, for each lesson, right? Then I have a lesson. This is a little bit like SQL, right? Then I say, okay, give me another lesson. Now I have 2 lessons. That's great. Now I want to have that they equal, that they have the same room. All right, here we go. And then we want to have an equal lesson time slot. All right, that's that.
Yeah.
And when you do that, then we have a problem. So then we're going to hit the solver on the head, say, okay, don't do that anymore. And then we say, okay, this is a hard, let's say hard. of hard one. This is a hard problem, right? And then we return that as a constraint, and we need to give it a name, right? And this allows you to, you can put filters in here. You can say, okay, just give me the lessons on, lessons on Monday, right? Where the time slot get day of week equals Monday, right? You could do things like that. So it's a very powerful API. It's very much inspired by the Streams 8, the Java 8 Streams API and SQL. But behind the scenes, it's also incremental. So that's why we couldn't just use, Java Streams. We had to actually create our own version of it because it needs to be.
But it looks familiar. You've got filters, join, and for each. It looks good.
Yeah. And you can go group bys, and it's very rich, of course, right? So you can handle any constraints you might need to have. Right?
This is awesome. Okay. Is there more? I mean, the API, actually, you just did a really good job. Is there more that we need to know basically about this?
No, but there's maybe one case. If you want to do like a vehicle routing case, then instead of using a normal variable like we've done here, we've said you can assign one time slot.
Right.
What you would then do is say, okay, I actually have a planning list variable, which means I have a list instead of, and then you have something typically looks like this. Okay, there's no visits here, but when you say I have a vehicle and that has a list of visits, right, like in the traveling salesman problem, then you need to have a list variable, and then we're going to fill in all of the variables into this list. There's one thing I didn't show earlier. Let me just jump on that. Indeed, there's one thing I didn't show you earlier. It's when you go to the timetable here. I didn't show this class. Now this class is the same in every one of our problems. In fact, we're thinking of making an abstract class for it that you can just reuse, right?
Right.
Yeah. And what it does is it just has a list of all of the time slots, a list of all of the rooms, a list of all of the lessons, and a score. This is the thing we gave back and forth. So when you looked at the controller, this was the class we sent. This is the data set we sent to the solver, and the data set we get back. Right?
That's so cool. That is so cool. So you have the ability to do one single variables or multiple variables as parameters. That's amazing.
Yeah.
And so for people who are wondering, you just go to start.spring.io. Does this work with? I haven't tried it yet, so I'll try it out as soon as we get off stream here pretty soon. But does this work with GraalVM native images by chance?
We have on our GitHub discussions, we have an entire post now how you use it on GraalVM. But we're improving the out-of-the-box support in the auto starter. So
nice.
It's so this is one of our biggest priorities right now.
Oh, that's so cool. I mean, this is already really cool. It's fast. I just want to see if it'll work. Maybe I can help you with that. Okay, this is super good. I don't think we need to do the podcast just because we talked it through. This is really, really great. Where do people find more about this?
Yeah, so start.spring.io if you want to start trying it out with Spring Boot, and you just add the Timefold dependency there. Let me just show you that. And of course, our website, so let me go, our website, Timefold AI too, right? So let me just share the first one here. This start.spring.io, you click here, you look for Timefold, right? And
nice website.
Yeah, and then, thank you. So, and then the other one is, of course, the, here we go. This is our website. I think it's zoomed in a bit too much.
Right.
Here we go.
AI.
Yeah, we went with the AI. So technically a solver is part of AI, but not machine learning. So we went with the AI stream. You can, it was a long debate whether we went with AI or AI. And then when you try this out, the really good one is, you go to the documentation, you'll get the things there. In our quick starts, which is gone right now. Okay, we have the link to the quick starts. We just changed it, but we actually have a quick starts repo too. Let me just quickly show it. And there you'll find a whole bunch of quick starts, right? So
where are you pasting this or showing this?
You cannot see my screen. Okay. So we have let me share my screen. Here we go. Yeah, so this is Timefold.ai. When you go here, you will find the documentation. That's where you can find the whole quick starts, which I just shown you a minute ago, right? And when you go to our repo, all right, in here we also have the quick starts repo, and you will find a whole bunch of quick starts in here too. Like for example, you'll find a quick start for employee scheduling, one for food packaging, one for maintenance scheduling, and so forth. All kinds of planning problems. And again, you cannot see my screen, so let me just.
I can see it. Oh, I saw it. I saw your website.
Okay. Yes. Okay. So what you can see in the quick starts repo, we have a whole bunch of quick starts there, which you can try out. And these are all kinds of different planning cases: vehicle routing, food packaging, employee scheduling, right? You start with the start.spring.io, and then you can copy some of the domains here, and you can start changing. So you can go in each of these use cases and say, I like this constraint, I want to copy that or want to learn from that while you build up your domain, basically. Right?
That's so cool. This is so cool. I will definitely have to do a live stream where I'm just like trying all this stuff out. But I like this. This is like you just took something that has made my head hurt and fit it into 30 minutes, and now it doesn't hurt. Just like this is perfect. This is really good. And how do you forgive me for being indelicate, but how do you make money? I hope you make money. I want you to make money. This is really cool.
Yeah.
But,
so we sell support on this, and we also have a high scalability feature. So it's a little bit like Kafka and stuff like that.
Yeah.
So we have two particular features. One is multi-threaded solving. So when you solve on one thread, typically you get good results. To maybe when you do 1,000 shifts, 2,000 shifts in shift scheduling, for example. But when you go to a lot of shifts, let's say 10,000, 100,000 shifts, then you're really already a big organization. You're probably already Fortune 500, right?
Right.
Then we have some we have some extra features for you where you can say, okay, I want to use 3-4 cores, and you get an additional speed up with that. And that's basically how that's our model. We did in the past, everything was, so in the Optoplanner area, everything was open source, but obviously there were some issues with that.
Right.
We are a bit of a niche technology. Almost everybody needs a database. Not everybody needs a solver.
Well, but if you do need one, see, this is the thing I think is really, I like these technologies. I like middleware for integration. I like workflow engines. I like rules engines. I like solvers. I think there's all this really cool stuff that, now we all talk about AI, but I think there's all this like stuff that has just been solving really, really big problems for the last 30 years. And people just don't know that there's a solution for this stuff already. This is one of those things where I'm just really happy to see it. And the fact that it's open source and that you can just start .spring.io, that is so cool. So cool.
And people are using this to plan their wedding tables, to give you an idea, to plan their tennis club schedules. It's just, you can try it out, you can play with it, and it's always fun to see how people use it all over the world for all kinds of crazy kinds of planning problems.
I love it.
Yeah.
This is very, very cool. Thank you. Wait. I'm sorry. Before we go, where are you on are you on the internet? Do you want to be found? And if so, where can people find you?
I'm on Twitter and LinkedIn. Just my name, Geoffrey De Smet, and you should be able to find me there. Yeah. We have a great YouTube channel on Timefold. So if you go to timefold.ai, and on the top right, you go to the YouTube channel. We have some shorts around planning videos, like how do you continuous planning and real-time planning, that kind of stuff.
Well, okay, hold on. So I got to find Geoffrey De Smet.
Yes. So yeah, just. So yeah, I'm on Twitter and on LinkedIn. And
can you put it in the comments?
Yes, no problem. Let me just do that. And of course, also on Mastodon, of course, right?
Yes, that's the new one. Let's see here, one sec.
There you go. I'll put it in the chat here, and so forth.
Okay, copy and paste. Here. Paste that. Okay, that's you on the internet if you want to be found. And then the website with the videos is...
Yes. If you just go to the Timefold website, you'll find a link at the top right. Right. So if you
contact pricing.
No. Top right. There's a YouTube. The whole
right next to it. It's so small, guy. You gotta
yeah.
Okay.
That's an internal discussion. How big should that be, right? And that's where we have
there you go. That one.
Yeah.
So like and subscribe. And then finally we have a question here. Has Red Hat started contributing to Timefold as it did with OptiPlanner? Does it have plans to do so? I don't know.
That's a good question. So Red Hat has not contributed to Timefold yet. They took one of our improvements and backported it to OptiPlanner, and we're happy with that, of course. But yeah, we're not seeing much activity on the OptiPlanner repo at this point in time. I would love to have continued it there too. It's just, it didn't fit within the continued company strategy. But we're, everything is quite amicably in the sense that there's no hard feelings there or with us. It's just a way forward, right? We really wanted to continue the project, and it's really, as you see what we've done in the last 6 months and improvements we've done, is we're really taking it up a notch and really adding more examples, adding more features, better integration with Spring, and yeah, that kind of things. We're playing also with more with Kotlin right now.
Nice.
Yeah. So all kinds of we're trying all kinds of things to make sure that wherever you guys want to use it, it makes sure that it works and it works well. Right.
That's so amazing. That's amazing. I love this community spirit. I love it. I love all the cool stuff you're doing. We'll have to do this again. Maybe we can just do it. Like this is a small, quick video for people who want to get started. But I would love to just sit there and hack with you at some point and just, we'll do a long one.
Good.
So thank you very much. Is it thank you well? No, thank you well. No. How do you say that? Is that Dutch? That's not Flemish.
Thank you well.
Thank you well. Yes, that. Thank you. And thanks everybody. Thanks for hanging out. Hope you got something out of it. YouTube.com/@Timefold and Twitter or X.com/Geoffrey De Smet.
Yeah, thank you. Thank you very much, Josh. This was fun to do, and thanks for having me.
Oh, my pleasure. Thank you. Bye, everybody.
Bye.